Now we're going to look specifically at autonomous systems. So recall some of the examples of autonomous systems that we saw before. So the standard exponential growth model. And also, let's see, Newton's law of cooling. So this is where we're proportional to the difference with the ambient temperature. And then the logistic growth model. So that was Kp m minus p, where m is the maximal or carrying capacity. And then, so these are, let's see, so we've got, this one's linear, this one's linear, this one's non-linear, because there's that p squared coming through there. And so in general and so the thing that makes these all autonomous is that the independent variable does not appear explicitly. So typically these would all be equations where p or u is a function of t, but you don't see any t's right here. And so now for systems, the kind of thing that we're going to be seeing for an autonomous equation is where we've got x prime is some function of x and y, not necessarily linear, and also our y prime is some function of x and y, again, not necessarily linear. So we can rewrite this as saying dx dt is some function of is some function of x like that, and then that our x at time t0 is some prescribed initial condition. And so in this situation here, we're looking at the vector x as being as having coordinates x and y, and this vector valued function f of x here, or if you prefer, f of x comma y, this is going to be the thing that has first coordinate capital fxy and second coordinate capital gxy. Right? Okay, so that's just to fixed notation. And since f and g do not depend on t explicitly, but only through the x and y of t that they have, then the solution for a given initial condition looks just like the solution for when you start at 0. So this is the time independence aspect. Okay, so to relate this to what we were looking at before, if we are looking at these matrix systems, then this one's going to be autonomous. When the matrix is allowed to depend on t, however, it might not be. And so the significance of an equation being autonomous for phase portraits is that the solution curves don't change when T naught does. And so what that means is that one phase portrait shows everything that can happen.